Yes guys, we're back again with another proof question, and this time we're proving that the area of a circle inscribed within a 3, 4, 5 right angled triangle is pi. So what do we need for this? Well, to find the area of this circle we need the radius for pi r squared. So let's start by breaking down this triangle. So we've got length 3, we've got length 4, then we've got length 5. Right, so we've got 3 there, 4 there, 5. Let's draw in our circle with radius r for now. So we need to obviously show that this radius is 1 plus pi times 1 squared is pi. So we're going to take a similar approach to as we done last time. So we know this length here is r, this is r. This means that this length here would be 3 minus r. Then similarly for the base, 4 minus r. And using these lengths, we can create more triangles within our main one. So we have a triangle here. Just make that a bit more clear. And then we've got, I should straighten that out. That should be r. And then, right, so why are we actually creating these triangles? Well, we need to establish that we actually already know what the area of the whole triangle is, and that's 3 times 4 over 2, which is 6. And, well, if we calculate the area of the triangle in terms of r, we can solve for r by equating to 6. Then that hopefully should give us 1. Now if we go back to this diagram here, we know the area of this is 3 minus r times r divided by 2. The area of this square at the bottom is r squared. The area here is 4 minus r times r over 2. This is a triangle. So we just need to find out the area of all this. Now, if we draw a tangent, if you draw the radius of this circle from the center to the tangent, which is length 5, we create another right angle triangle. Here we have length r. But we do not know what this length is. Neither do you know what this length is. Well, if you see, this has been poorly drawn. Let's draw this a bit better. Oops, still hasn't done it. There we go, that's a bit better. That's that, that's that. We see here that these two triangles here, so we've got one there and another here. These are just the same. Why is that? Well, we have a right angle here, so that's our angle. We have both r, and they share 2 side lengths. So there's one r there. So there's one side length there and another side length there, which are both the same. So we can say that this here is 3 minus r. Using a similar logic here, so we have right angle there, that's our angle. We need 2 sides for congruency, or in this, and in this case we've got the r here and this length there, so we can safely say that this is 4 minus r. Now, we can either, well, there's 2 ways of going about this. We can say that 3 minus r plus 4 minus r equals 5. That means 7 minus 2r equals 5. 2r equals 2, meaning r equals 1. That's one way of finding r. And there's a slightly more complicated way. So we can show that we can't show that, we can use the idea that the area of this whole triangle is 6 to, well, we can also form the triangle of the area of this triangle using all these mini triangles and 1 square. So let's go ahead and do that. So we have r squared here. We've got 3 minus r over 2 times r multiplied by, well, 2, because we've got 2 of these triangles. And then we've also got 4 minus r times r all over 2. And again, we've got 2 of those triangles. And we know that equals to 6. So immediately we can cancel these 2's. Start solving. So we have r squared plus 3 times r is 3r minus r squared plus 4 times r, which is r, minus r squared, minus r times r, which is r squared, equal to 6. Group the r squareds, so we have r squared minus r squared minus r squared, so minus r squared plus 7r equals 6. Rearrange for 0 on the right hand side, so r squared goes over, so there's a 7r, and the 6 remains where it is, so we would have a 0. And then factorize, so r minus 1, r minus 6, which equals 0. So r equals 1 and 6. Well, we've got 2 solutions, so we also need to reject 6, but how can we? Well, if we go back to our diagram here, we know that this length here is 3, and 3 is obviously greater than r. So since r is greater than, let's go again. 3 is greater than r, so that means r must be less than 3. So if r is less than 3, we can reject 6 and say that r equals 1. So now using this r equals 1, area of a circle equals pi r squared, which is pi times 1 squared, which equals pi. That is this question proven. So now you know that the area of the circle within a 3, 4, 5 triangle or circle is pi. Nice.